Hi friends, in the last lecture on advanced machining processes, we have seen different machining processes, chemical machining, electrochemical machining, then EDM, electro discharge machining, wire EDM, laser beam machining. Now, in continuation with that, we will see now the next process, electron beam machining, that is EBM. Now, in this process, the high velocity electron beam, after leaving the anode, passes through the tungsten diaphragm and then through the electromagnetic focusing lens. So focusing lenses are used here to focus the electron beam on the desired spot of the workpiece. When the electron beam impacts on the workpiece, the kinetic energy of the high velocity electrons is immediately converted into heat energy, and due to this, high intensity heat is produced which melts and vaporizes the workpiece material at the spot of beam impact. This is the sketch of this electron beam machining. That means this is the anode and this is the electron stream which is passing through the focusing length, and after passing focusing length it impacts on the workpiece. Immediately its kinetic energy, that is when electron beams are passing through this, it possesses the kinetic energy, and when it impacts on the workpiece its kinetic energy gets converted into heat energy. And here if you see, there intense heat is produced in this area, and this part of the workpiece vaporizes, melts and vaporizes. In this way the EBM works. Now the next process is electrical discharge grinding process. It is EDG. So electrical discharge grinding is non-traditional thermal process for machining hard and brittle electrically conductive material. EDG has been developed by replacing the stationary electrode which are used in the EDM process. In EDM process, the electrodes are stationary. Here in this, they are replaced by rotating electrode. So electrical discharge grinding is similar to electric discharge machining, but with the tool in the form of rotating conductive wheel, or which is called as a grinding wheel, and with lower currents. Here you can see very well, here is a rotary mechanism, a servo system is there, and this is the metallic wheel, and the dielectric here, and here is the workpiece. Now this process is very much similar to grinding process, but here additional to grinding process, they use dielectric between the workpiece and the tool. Here you can see this is the workpiece and this is the tool. In between there is a dielectric. And we connect the polarity to positive and negative terminal. That means the grinding wheel is made cathode, that is the negative terminal, and the workpiece to be grinded is made anode. So MRR in this process, that is material removal rate, is quite large in this process, that is about 25 cm cube per hour, and tolerances achieved are 0.025 mm. This process is generally used for hard to process material or hard to grind materials. The next process is water jet machining. So water jet technology uses the principle of pressurizing water to extremely high pressures and allowing the water to escape through a very small opening called orifice or jewel. Water jet cutting uses the beam of water exiting the orifice to cut soft materials. This method is not suitable for cutting hard materials. So the inlet water is typically pressurized between 1300 to 4000 bars. This high pressure is then forced through a tiny hole in the jewel, which is typically 0.18 to 0.4 mm in diameter. You can say very well say this is the inlet water over here, and this is called as the jewel. The water inside it is pressurized, and this is pressurized water is pass escape or high pressure and allow the water to escape through a very small opening, that is orifice or jewel. The next one is abrasive jet machining. Abrasive jet machining is an extended version of water jet cutting in which water jet contains abrasive particles such as silicon carbide or aluminum oxide in order to increase the material removal rate above that of water jet machining. So as compared to water jet machining, abrasive jet machining is more effective. In this, abrasive particles are used. And almost any type of material ranging from hard brittle materials such as ceramics, metals and glass to extremely soft materials such as foam and rubbers can be cut by abrasive water jet cutting, which is not possible with water jet machining. They are only used for the soft material, but in case of abrasive jet machining, you can go for hard materials also. Here in this process, you can see high velocity water exiting the jewel. This is the jewel and this is the high velocity water which is exiting the jewel, creates a vacuum which sucks abrasive from the abrasive line. This is the abrasive line. Here you can very well see this is the abrasive line, and the water when escaping from this area, it sucks the abrasives from the abrasive line which mix with the water. Then when it sucks, it get mixed with the water in the mixing tube to form high velocity beam of abrasive. Here only you can have water, but when it passes through this abrasive jet line, it sucks the abrasive particles, and after that the water which is in the form of abrasive, it is flowing through this tube. So this is about our all advanced machining processes. So thank you very much to all of you. Thank you.